Hi everybody, this is Nathan again, and I'm making a movie to try and show you how to use the calculator to deal with z-scores that you get from knowing a mean and a standard deviation and being able to determine the probability from there. So, the title is Using Normal CDF from your left-hand z-score to your right-hand z-score to find the area underneath the normal curve, which by the way is the probability. Alright, so through this whole big set of data, whatever this big set of data is, you pull out that the mean is 32 and the standard deviation is 2. What you're trying to find is that the probability of some individual score, data point, whatever, is between 28 and 34. The z-score formula at this point in time is you take the raw data point score minus the mean and divide it by the standard deviation. So to make this work, the normal CDF work, we've got to convert the 28 to a z-score formula. Or to a z-score, forgive me. And so we take the 28 minus 32, divide it by 2, and we get a negative 2. We take the 34 minus the 32 and divide it by 2, and we get 1. We're going to hit the second key, the vars key, normal CDF, and then negative 2 to 1. All right. Now, if I was doing that on my calculator, I would turn it on. I would find the second key. I'd hit the vars key. And number 2. Never do we use number 1 in this class. Okay, so normal CDF. And then we type in negative 2. The negative key is down here. That's the subtraction key. If you hit the subtraction key, it gets all mad at you. So negative 2, hit the comma key, then the 1, and then you hit, oops, let me get that to show. Then you hit your enter, and you get 0.81. So you had an 81% chance, or your probability is 81 or 82% if you round up. Okay, so you have an 82% chance of finding something that is between, if it was heights, say 28 inches to 34 inches. All right. The next one that's listed below. It says, what if we just wanted to find strictly less than 34? Which means from negative infinity up to 34. So we're going to hit the second vars normal CDF. We don't have a negative infinity key. So what we use is negative 10,000. And then we come up to the 1. We already got the 34's z-score from over here. So, again, second vars. Hit the wrong key. Second vars, down to number 2. I'll type negative 10,000. There it is, negative 10,000. I need one more 0. I hit my comma. I hit my 1, my parenthesis, and my enter. And that's 84% of the area. Now, I'm going to put something else up on here. It's called the empirical rule. And how does z-score relate to the empirical rule? Well, the empirical rule is basically the normal curve where your mean, in this case would be the 32, this would be 34, that's one standard deviation away. Here's your 36, here's your 38, so on and so forth. It just keeps going. Then you're at 30. Then you're at 28, then you're at 26. The mean is 0 standard deviations away from the mean. I know that's goofy to say, but that's why its z-score is 0. 34 is 1 standard deviation away, so its z-score is 1. 36 is 2 standard deviations away, so its z-score is 2. 38 is 3 standard deviations away, so its z-score is 3. And we can go the other direction. So negative 1, negative 2, negative 3. And they go on to negative and positive infinity. And since we don't have a negative and positive infinity key on our calculator, we use the negative 10,000 and the positive 10,000. And the empirical rule has these pieces in it. The probability is about 34% here, about 34% there. They're symmetric. This is about 13.5%, 13.5%. This is 2.35%, 2.35%, 0.15%, and 0.15%. Okay? That 0.15% carries on off to infinity and off to negative infinity. So, I hope that helps a little bit. We're going to stop the video now.